So welcome back to the channel and to the video, and today I'm going to solve some hyperbolic functions. So here are the problems that were given to us, and we're going to solve them one by one. So the first problem is the sine of hyperbolic times 0.942 plus j 0.429. So we all know the formula for the sine hyperbolic is just equal to the sine h of your x, which is your 0.942, plus your cos of your y is 0.429, plus your j of your hyperbolic cosine of your x is 0.942 times your sine of 0.429. Then calculator. So let's complex, then rad. So we have hyperbolic sine 0.942 times your cosine 0.429 plus hyperbolic cosine of 0.942 times your sine 0.429i, and then shift complex 4. So we get here 0.99 plus j 0.61. Next, we have the cos hyperbolic of 0.942 plus j 0.429. In this case, we know the formula. So the formula here is just the cos hyperbolic of 0.942 times your cos 0.429 minus, this will be sine h of 0.942 times sine of 0.429. Calculator again. So 2 here 0.942 times your cosine 0.429 minus sine hyperbolic of 0.942 times your sine of 0.429. Oh, sorry, I forgot to put I. And shift complex 4 to rectangular, and we have here 1.34 minus j 0.45. And our last number is hyperbolic cosine squared 0.924 plus j 0.429 minus sine hyperbolic squared of 0.942 plus j 0.429. So here what I did is I used the trigo identities. So the cos h squared of x is just 1/2 of your cos hyperbolic 2x plus 1. And here on the sine is just identity of 1/2 of cosine hyperbolic 2x minus 1. So we just convert it here. So I put here 1/2 of your cos h2 times the angle of your complex numbers here plus 1, then minus 1/2 of your cos h of 2 times 0.942 plus j 0.429 minus 1. Then I further simplify this, so I get here 1/2. I took out all the 1/2, so what is left here is just cos h of 2.848 plus j 0.058. This would be minus sine, cos h. We have here 0.884 plus j 0.858. Then we use the hyperbolic formula, the hyperbolic formula of your cos, of course, of it. Then we use the hyperbolic. Then we use the hyperbolic function of your cosine. So we get the cosine of 2.848 and cos on 0.858 minus sine h 2.848 times sine of 0.858, then minus cos h of 0.884 times cos of 0.858 minus the sine h 0.884 sine 0.858. Then calculator again. So 1/2 of the cos of the cos h 2.848 cos 0.858 minus sine h 2.848 sine of 0.858 minus the cos of h 0.884 cosine of 0.858 minus sine h 0.884 sine of 0.858, and don't forget to put the I. So I forgot to put here I here in the paper and also in the calculator. So let me just edit it in. So here I. It was up, so we have to put here I or J. Shift complex for so again for equal. So the answer here is 2.37 minus J 3.63. Okay, so our next problem is the inverse hyperbolic. So our first problem is the arc side h of 1 minus j2. So we let a equal to the arc side h 1 minus j2. Then transfer to the other side, we have side h a equal to 1 minus j2. Then we convert this to exponential, so we have e raised to a minus e raised to negative a over 2 equal to 1 minus j2. Multiply this to the other side, so we have e a minus e negative raised to negative a equal to 2 minus j4. Then we multiply this by e raised to a, so we get e raised to a squared minus 1 equals to 2 minus j4 equals to e raised to a. And we transfer this to the other side, so we get e squared minus 2 minus j4 e raised to a minus 1 equals to 0. So we have now in the quadratic equation, so e raised to a equal to negative b, so it's 2 minus j4 plus minus square root of your b squared, so it's 2 minus j4 squared minus 4 times your a 1 times your c negative 1 all over 2a, so 1. Next we simplify this, so e raised to a is equal to 2 minus j4 plus minus square root of this, so this is 4 negative j8 plus 16 minus plus 4 all over 2. Simplify this further, so we have 24. So e raised to a equal to 2 minus j4 plus minus square root of this 24 minus j8 all over 2. You can factor this out here, so a squared, e raised to a, so it's minus j, or you can factor this out already, so this will be 1 of 2 plus minus, so this will be a, then 4 times 2, so This will be 4 times 2 times, so 8 divided by 24 divided by 8, that will be 3, and 8 divided by 8, so that's 1, so j 1 over 2. Then we can factor this out because it is a perfect square. So a is equal to 2, 1 minus j2 plus minus 2 square root of 2, 3 minus j 1 over 2, cancel out, and times it by the ln. So we get a equal to ln of 1 minus j2 plus minus square root of 2, 3 minus j. And the final answer for the arc sine of h, 1 minus j2 equal to 1 half of ln 1 minus j2 plus minus of 2, 3 minus j square root. So the next one is the arc cos h of your 1 minus j2. So we let a equal to arc cos h 1 minus j2. Transfer this to the other side. So the cos h of a equal to 1 minus j2. Convert the cos h into the exponential. So e raised to a plus e raised to negative a over 2 equal to 1 minus j2. Multiply this to the other side. So then we have e raised to a plus e raised to negative a equal to 2 minus j4. Multiply by e raised to a squared plus 1 equal to 2 minus j4 times e raised to a. Transfer this to the other side. So you have e raised to a squared minus 2 minus j4 e raised to a plus 1 equals to 0. So we have a quadratic formula or quadratic equation. So e raised to a equal to your b, which is negative b, so it's 2 minus j4 plus minus the square root of your b, so 2 minus j4 squared minus 4 times your a times your c all over your 2 of your a. Simplified further, so e raised to a equal to 2 minus j4 plus minus square root of your 4 minus j8 plus 16 minus 4 all over 2. Here simplified further, e raised to a equals to 2 minus j4 plus minus square root, so this will be 16 minus j8 all over 2. Simplify this, so we took out the 8 and 8 can be has the product of 4 and 2, so the 4 is a perfect square. So you have e raised to a equals to, we factor out, so 2 1 minus j2 plus minus 2, and what's left inside is just 2 times 1 or 2 minus j all over 2. Cancel out and multiply by ln. So what is left is a equal to ln of 1 minus j2 plus minus square root of your 2 times 2 minus j, and the answer for the arc cos h of 1 minus j2 equal to ln of 1 minus j2 plus minus square root of 2 times 2 minus j. Lastly, we have the arc tan of h1 minus 2j. So we let a equal to arc tan h1 minus 2j. Transfer arc tan to the other side, so we have tan h a equal to 1 minus 2j. Transform this to the exponential form, so it's e a minus e raised to negative a all over e a plus e raised to negative a equal to 1 minus 2j. Multiply this to the other side, so we have e a minus e raised to negative a equal to 1 minus 2j times e a plus e raised to negative a. Simplified further, e raised to a minus e raised to negative a equals to e a plus e negative a minus 2j e a plus minus 2j e raised to negative a. Multiply this by e raised to a both sides, so e a squared minus 1 equals to e a squared plus 1, and we have here minus 2j a squared minus 2j. Then we transferred all with ea squared to the other side. So ea squared minus ea squared plus 2j ea squared equal to 1 plus 1 minus 2j. So this will be 0, and what is left is 2j ea squared equal to 2 minus 2j. And we divide this by 2j, so e raised to a squared equals 2 minus 2j over 2j. We can factor this out, factor out the 2. So what's left? ea squared equal to 1 minus j all over j. Then we square root both sides and times with ln. And what is left is your a equal to ln of the square root of 1 minus j over j, and simplified further, and our answer for the arctangent h of 1 minus 2j equal to the 1/2 ln times ln of 1 minus j over j. Thank you so much for watching the video. I learned that the hyperbolic functions and the trigonometric functions and also their inverse are very similar. What I mean similar is that the problems are so difficult, but with practice and more practice, and I will be able to solve. And thank you so much, and see you in the next video.